Hi, my name is Aditya and today I'm going to explain how I have applied different classification models on my dataset, which is about poker hand prediction. I'll be showing how different algorithms can be used to predict the possible poker hands. So, what first of all is a poker hand? In poker, players structure sets of 5 cards called hands as per the principles of the game. Each hand has a position, which is looked at against the positions of different hands, taking an interest in the standoff to choose who wins the pot. Here is an example of a poker hand. This is a straight flush, 5, 6, 7, 8, 9 of the same suite. This represents a straight flush. So in my data set, each record is an example of a hand consisting of 5 playing cards drawn from a standard deck of 52. Each card is described using 2 attributes, suit and rank, for a total of 10 predictive attributes. There is one class attribute that describes the poker hand. The other order of cards is important, which is why there are 480 possible royal flush hands as compared to 4. I have picked up my data source from UCL archive and it is poker hand dataset. Here is my dataset attribute description, where each attribute is either the rank of the card or the suit of the card. And finally, there is the target variable or the class variable to the poker hand. Now, then there are the different types of poker hands which are existing in a card game. In total, there are 10, as you can see here, from 0 to 9. So now I'll start with the coding part and how I have applied various classification algorithms on my dataset. First, I have imported all the libraries, the important libraries which will help me to get the result and the validation accuracies of my model. So here, as you can see, it's the same code on the Google Colab. So here I have downloaded all the important libraries. Then I need to pre-process the data, for which I have used. So as you can see here, I have pre-processed the data, which is I have separated the training and the testing data, and will now use it to apply my different algorithms. First, I'll be applying neural network on my dataset. A neural network is a progression of algorithms that attempts to perceive fundamental connections in a lot of information through a procedure that copies the manner in which the human brain works. It can be adjusted to changing input, so the network produces the most ideal outcome without expecting to redesign the output's criteria. To create the neural network, I have used Keras library, which is a high-level API wrapper for the low-level API, capable of running on top of TensorFlow, CNTK, or Theano. My neural network architecture comprised of 3 dense layers with respectively 15, 10, and 10 nodes in each layer. Here is the code for that. Here I have used to evaluate my accuracy, my validation accuracy, which shows how my model has fitted on top of each other. So as you can see, my validation accuracy, the first epoch comes out to be 89.99%, but in the significant epochs, it is rising up to 90.04%. So my validation accuracy when I use neural networks is coming out to be 90.04%. Here you can see how my graphs, how my training and testing graphs are fitting on top of each other. Then I have used logistic regression. Like all regression analysis, logistic regression is a predictive analysis. Logistic regression is used to describe data and to explain the relationship between one dependent binary variable and one or more nominal, ordinal, interval, or ratio level independent variables. Here I have used the scikit-learn library to import all algorithms and employed the logistic regression method of model selection to use logistic regression algorithm. Here I have used the accuracy score to predict my validation accuracy, which is coming out to be 50.12%. So as you can see, the validation accuracy is surprisingly low as compared to that of neural network. It is because neural network is a far more complex algorithm which which gives a which runs on many training scenarios and helps to fit the data in a better way. Classification and regression trees for machine learning called CART. I have used CART algorithm next. It is a short term introduced by Leo Bremen to refer to decision tree algorithms that can be used for classification or regression predictive modeling problems. The CART algorithm provides a foundation for important algorithms like bagged decision trees, random forest, and boosted decision trees. I use the scikit library to import all algorithms and employ the decision tree method of model selection to use decision tree algorithm. Here I have used accuracies, I have tried to predict the validation accuracy, which is again coming out to be exactly same as that of logistic regression at 50.12%. Then finally I have used support vector machine SVM. It is a machine learning algorithm which can be used for both classification or regression challenges. However, it is mostly used in classification problems. In this algorithm, we plot each data item as a point in n-dimensional space, with the value of each feature being the value of a particular coordinate. Here, the validation accuracy is coming out to be 43.16%, which is even lesser to that of logistic regression and CART. Here you can see my complete code, which you can also open it in Google Colab and see my working. In the end, the neural network using Keras library enables us to produce the most accurate results above all. This is one of my first applications in machine learning. Thank you for reading my article, and I hope I was able to help and inspire students like myself. Hope you can try it by yourself now. Thank you.